Hi, welcome to Fun with Algorithms. In this video, I am going to talk about level order traversal of tree data structure. And this is also a good starting problem to understand how two different data structures can be used together to solve a particular problem. Now, if you like these kind of videos, please do subscribe so that you will receive notifications on my new videos. Let's get started. There are many ways of traversing a tree, but there are four common ways in which we generally traverse the tree. They are pre-order traversal, in-order traversal, post-order traversal, and level order traversal. I have covered first three traversals along with basic introduction to generic tree data structure and binary trees in a different video. I will leave the link to that video in the description down below. If you haven't seen that, please do check it out before watching this video. In this video, I will cover level order traversal in detail. Now consider this binary tree. Before solving level order traversal, let's first understand what do we mean by level in the context of trees. We can define level as the distance of a node from root node, or in other words, it's the number of arrows between a node and a root. So root node, which is node 6 in this picture, is at level 0. Direct children of root node, which in this example are nodes 4 and 7, are at level 1 as there's only one arrow between root node and these nodes. Similarly, nodes 2, 5 and 8 are at level 2 since all these nodes are at a distance 2, or it takes 2 arrows to reach these nodes from root node. I think by now we got the hang of what level in a tree means, right? Now, level order traversal basically means you traverse the tree one level after another. That is, we first process all nodes of level 1 before processing any node of level 2. Now, here we can't directly use recursion unlike basic traversals, because when we traverse tree recursively, we process the entire subtree first before moving on to different subtree. That means when we are processing subtree, say rooted at node 4, we end up processing all the lower level nodes before even processing node 7, which is at level 1. So we take a different approach here. When we start at root node and then take its children, we get all the nodes at level 1. So we keep it in some place. Now this place contains all the level 1 nodes. So if we take children of all the nodes from this place, then we get all level 2 nodes. Now we see that we are getting nodes one level after another, which is what we want. And also we are getting nodes first from level 0, then level 1, level 2 and so on, which is the order in which we actually want to process the tree. That is, whatever level comes first, we want to process it first. I think you may have guessed what data structure needs to be used to store the nodes, right? That's right, we will use queue to store the nodes and process the tree using level order traversal. Now in this video, whenever we visit a node, we color it in orange, and when we process it, we color it in red and also print its value on the right side so that order of processing is clearer. So to start with, we take an empty queue and put root node in it. In each iteration, we take the node which is at the head of the queue, and now we consider that node as visited. So we mark them in orange. In first iteration, it's always root node or node 6 in our case. We put children of this node in the queue and then process the node that we have. That is end of one iteration. We repeat the same process till the queue is empty. So in next iteration, we get node 4 from the queue. We add its children's node 2 and 5 before processing it. And once we process the last node of level 1, which is node 7, we have completely processed all nodes in levels 0 and 1. Now, if you look at the queue, all nodes in the queue are from level 2, that is nodes 2, 5 and 8. So you're observing how we are processing nodes one level after another, right? We continue the same process now for all nodes of further levels. Now, once we process the last node of last level, which in our case is node 3, the queue gets empty. This is our queue for us to stop execution. No pun intended. This is how level order works. Now, let's look at the code for the implementation of this algorithm. So I have this code opened here in VS Code with two files, tree.go and levelorder.go. Tree.go has the implementation for tree node, which is what we are going to pass into level order function defined in levelorder.go. Here we pass the root node of the tree to this function. In this function, we first create an empty queue. Implementation of queue is out of scope for this video, but if you want me to make a video on queues, please do leave a comment. Now, next thing we do is we put root node in the queue, and then in for loop we check if queue is empty. If not, we remove the element from queue, add its left and right child to the queue if they are not null, and process the node that we have just taken out, or in this case print its data. We repeat the same process till all nodes are processed, and once done, queue will become empty, and then we terminate the traversal. So that's all about level order tree traversal. If you like this video, please do like, comment, share and subscribe. And don't forget to press the bell icon to receive notifications on my new videos. See you next week. Thank you.